The teslapiphone, expected to arrive in 2026 as Elon Musk envisions, could redefine expectations for durability and everyday usability. Beyond the usual concerns of bending, warping, dirt, or accidental drops, the real innovation may lie in its frame, designed to handle the stresses of daily use while allowing the shell to function almost like a simple protective jacket. Central to this is the X chassis frame, which forms the backbone of the phone. Every drop, torsion, or exposure to dust and oil applies stress to the structural core, and by placing it at the heart of the design, users can worry less about incidental damage and more about the experience of using the phone. The approach combines multiple strategies: a robust X chassis layout, careful material selection, replaceable corner modules, and enhanced grip solutions. Together, these elements create a comprehensive durability system. For instance, if a 220-gram teslapiphone were to drop from 1.88 meters onto concrete, the impact energy would be around 3.9 joules. If that impact occurs at a corner with a stopping distance of about 1 millimeter, the peak force could reach almost 3,900 newtons. The X chassis architecture mitigates this by using diagonal ribs that redirect impact forces away from the point of contact, reducing local deformation and protecting the display and internal components. Finite element simulations on similar designs suggest that diagonal ribs can increase bending stiffness by 15 to 25% compared to thin, ribless frames, providing a larger safety margin for severe drops. Architecture alone is not sufficient. Material selection is equally critical. Utilizing 7000 series aluminum for the main frame and reinforcing the corners with high-strength steel balances weight with structural integrity. Aluminum 7075 T6 offers a yield strength of 480 to 520 megapascals and a modulus of 71 gigapascals, providing stiffness at small thicknesses, while steel alloys such as 174 pH or stainless steel at corner ribs yield strengths of 700 to 1,100 megapascals and a modulus of roughly 200 gigapascals, delivering excellent localized compression resistance. Each steel corner rib adds minimal mass, around 2 to 5 grams, but significantly improves impact absorption. Mechanical pins combined with structural adhesives ensure even stress distribution across aluminum steel joints, lowering the risk of cracking after repeated drops. Equally important is reducing accidental slips. When hands are sweaty or slightly oily, friction drops from around 0.5 to 0.6 to 0.25 to 0.35, increasing the risk of drops. The teslapiphone incorporates longitudinal grooves along the frame, 0.8 to 1.2 millimeters deep and 1.5 to 2.0 millimeters wide, which engage the fingertips and improve grip by 20 to 40%. A micro-texture and durable PVD anti-oil coating maintain this grip over months of use, reducing drop frequency significantly. While a strong frame addresses severe accidents, everyday scuffs and scratches remain an issue, which is why the teslapiphone includes a utility clear case. This case combines an aliphatic TPU rim with a 1 millimeter thick optical polycarbonate back, coated for UV and oil resistance, maintaining light transmission above 92% and minimizing yellowing even after years of exposure. The interior features dust drainage grooves to prevent clouding and enable quick cleaning under running water. And the case attaches via 4 snap-on points capable of withstanding over 150 newtons and more than 500 removal cycles without loss of grip. Raised lips of 1 millimeter above the display and camera glass prevent scratches, while a 2-layer design with a TPU inner layer for force absorption and a polycarbonate outer layer for smooth touch balances protection and usability. The case weighs under 30 grams and increases overall thickness by only 1.0 to 1.2 millimeters, keeping it compact while preserving edge gestures. Shallow grooves and micro-textured TPU rims further improve grip under humid conditions, reducing accidental drops. The teslapiphone also enables user maintenance with exposed screws and red silicone gaskets. These components allow simple at-home procedures like opening the phone, cleaning speakers, clearing ports, or replacing gaskets without professional tools. 4 Torx T4 screws, M1.6x 3 millimeters in size, secure the top frame with a tight yet removable hold. Removing screws in an X pattern, accessing components, and reassembling with proper torque maintains water and dust resistance. Red gaskets function under 20 to 30% compression, with color indicating wear. Replacement is straightforward, with instructions to wipe grooves, insert new gaskets without overstretching, and test water resistance via a simple droplet method. A pull-out dust filter tray keeps speakers free of debris, maintaining sound quality. The teslapiphone introduces glove mode hardware for winter use, featuring a large utility button and tactile, textured surfaces that allow flashlight use, QR scanning, and quick calls with gloves up to 3 to 4 millimeters thick. The power and utility buttons have distinct textures and spacing optimized for tactile distinction, reducing mispresses by over 40% compared to flat designs. An anti-slip rim around the utility button prevents accidental activation, and TPU layered over polycarbonate ensures compression resistance without permanent deformation. Recognizing that phones often serve as tools in varied environments, Tesla equips the PiPhone with maglock mounts, a multi-point magnetic and mechanical system for secure attachment in vehicles, workshops, or walls. Internal tests simulate rough road vibrations of plus or minus 1.5 G for 20 minutes without detachment, and standard screw holes enable attachment to existing mounts without proprietary accessories. A built-in lanyard loop allows users to secure the phone during tasks at height, reducing drop distance and preventing damage. Ultimately, the teslapiphone is positioned not merely as another smartphone, but as a practical, durable tool engineered for demanding conditions, from construction sites to daily commutes. Its reinforced frame, modular protection system, user-centric maintenance features, and thoughtful interface design demonstrate that durability extends beyond toughness, encompassing intelligent engineering from the inside out. Tesla envisions a device built to thrive under pressure, setting a precedent for future technology that emphasizes resilience and real-world usability. For enthusiasts curious about innovations that challenge conventional expectations, following Drive Tech Tesla, and staying updated promises insight into devices that may redefine our relationship with technology. Apple is preparing one of the biggest changes in the history of the iPhone lineup by splitting the iPhone 18 release across 2 phases, a move that will completely shift the usual rhythm of its launches. Instead of unveiling the entire family together in fall 2026, Apple will place all attention on the higher-end models first, introducing only the iPhone 18 Pro, the iPhone 18 Pro Max, and the long-anticipated iPhone 18 Fold on the main stage. As a result, the most affordable phones available during that launch period will still come with starting prices around $1,999, positioning the baseline models almost as an afterthought. After years of resisting the foldable phone category, Apple now appears to be giving in to market pressure, acknowledging that the demand for flexible devices has grown too significant to overlook. But while Apple finally steps into this space, the conversation is increasingly being dominated by the teslapiphone, a device that embraces a foldable design language with far more aggression and pairs it with features that feel entirely different from what traditional smartphone makers have been offering. Despite the strong ecosystems and deep customer loyalty enjoyed by Apple and Samsung, Tesla believes it can compete directly,